A geometric sequence is a sequence in which each term after the first is found by multiplying the previous term. The one we looked at in our warm-up was a geometric sequence because we were doubling it, multiplying by 2. That constant r is called the common ratio. With the arithmetic sequences, it was d, the common difference, because we were subtracting to find out how much we were adding every time. Well, here we're going to divide to find out what we're multiplying by every time. And we can divide the second term, a2, by the first term, a1, to find r. So a2 divided by a1 is equal to your common ratio. So the formula, which we looked at in a warm-up as well, for our geometric sequence is an equals a1 times r to the n minus 1 power. This should look familiar to you. Like y equals ab to the x, which represented our zombie growth and our zombie apocalypse problem because the population was doubling or tripling. So a geometric series or sequence represents exponential growth. Okay, so we're going to find the missing term. Our pattern goes 324, 108, 36, 12. What is the pattern? Dividing by 3, but we talk about what we're going to multiply by. So r is 1/3. And I can get that by taking 108 and dividing by 302. But I could also get that dividing by 12 by 36, which I can do in my head, right? So 12 over 36 is your 1/3, and that's your common ratio. So if I divide by 3 again, what's my missing term? 4. Okay? So do the next one. So if I don't see right away what I'm multiplying by, I can use my calculator and divide. R is going to be 24 divided by 16. Which is what when I reduce it? 3 halves, right? Because I can divide 24 and 16 by 8. And then I can multiply 54 times 3 halves to get my next term, which is 27 times 3, 81. Where did I get 27 times 3? I divided the 54 because it's even by the 2. Oh, I should be doing that here. 54 divided by 2 is 27. 27 times 3 is 81. Of course, you can do that in your calculator. Yes? Yes, I can always use the second term divided by the first term to find my common ratio. I can actually use any two numbers, but I have to use like the third divided by the second, or the fourth divided by the third to get my common ratio. Okay? Okay, so our next example, find the sixth term for the geometric series for which a1 is -3 and r is -2. So one thing that's different about our sequences and series from our exponential growth and decay is r is allowed to be negative. When we did exponential growth and decay, b, the base of our exponential, was not allowed to be negative. So if my first term is, let's do it the long way first. If my first term is -3, what's my next term? +6. What did I do? I multiplied by r. Now what's my next term? -12. And my next term? +24. And my next term? And then my sixth term? positive 96. So my sixth term, A6, is 96. Now, can I use the formula? Could I have used the formula to do that? Remember, my formula was AN equals A1 times R to the N minus 1. So to use my formula, I could say A6 is, what's my A1? Negative 3 times negative 2 to the 6 minus 1 power. So negative 3 times negative 2 to the 5th power, which is negative 3 times negative 32, which is positive 96. So the formula is nice when we want to find a big term, right? We could do 6 by hand.
But if it was like 30.
Right, if I want to find the 30th term or the 50th term, I definitely want to be using the formula and plugging in that number for n. Questions?
No.
Try the next one on your own. Find the 5th term for the geometric series for which a1 equals negative 4 and r is positive 2. Okay, so let's do this one using the formula. If my A5 is what I want to find, right? My A1 is negative 4. My R is 2 to the n minus 1, which is 5 minus 1. That's negative 4 times 2 to the 4th, which is negative 4 times 16. Negative 64 is your 5th term. And if you wrote it out, you got that as well, right? So we're looking at writing the equation of the sequence. And then we're going to find A7. So again, let me write the formula at the top so we remember. By the end of this chapter, we're going to have about 5 formulas.
For logs, we had like 27 or something.
That's a times. It's a bad times, but... So, yep. I'll give you a second. Find R, and then can you write the formula for the first? Okay. So, looking at this, what's your common ratio? 2, right? We should be able to find that one just by looking at it. If you don't see it, 10 divided by 5 is 2. And what's my first term? So A1 is 5. So my rule, or the equation, is AN equals 5 times 2 to the n minus 1. That's my rule. It's the easiest one to write because I don't have to do any solving to write it. And then to find A7, I plug in 7. Right? That's what that means. Find A7. Find the 7th term. Plug in 7. 5 times 2 to the 6th power. 2 to the 6th power is 64. And that is 320. So A7 is 320. So give the next one a try. Okay, let's do my last problem. What's my R? 2, 6, 18. R is 3. And my A1 is 2. So what's my equation? AN equals 3. Oops. Wrong number, right? A1, 2 times 3 to the n minus 1. And then, so my equation has 2 variables, right? N here and AN. That's my rule in my equation. And to find A6, 2 times 3 to the 6 minus 1. 2 times 3 to the 5th. What is 3 to the 5th? 243. And 2 times that is 486 is your A6. Okay, so your homework is number 56 on page 430. 430, 5 to 21 odd. Okay, just these two examples we did. We'll do the other ones on Thursday and Friday. Thursday, you're not going to have the whole period to do the quiz.